بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will see the last video concerning probability, and we will see the probability tree. Before we talk about the probability tree, let's talk about independent events. A and B are two events of the same random experiment. A and B are independent if and only if the probability of A given B is the probability of A, or the probability of A intersection B is the probability of A times the probability of B. So to tell whether two events are independent or not, we use one of these two rules. Let's see this example. A and B are two events. The question is, are A and B independent or not? Well, which formula do we use? It depends, in fact, on the given. I think we're going to use the second one because it's more suitable than the first one for the given. Well, what is P of A times P of B? It's 0.2, and it's equal to the probability of A intersection B, which means that A and B are independent. Now let's see this application. E and F are two events, and the question is also, are E and F independent or not? Try to do it alone. Well, here it's preferable to use the first rule, and the probability of E given F, which is 0.25, is not equal to the probability of E, which is 0.5, which means that E and F are not independent events. Now, this is the list that we have to remember. Now let's see this kind of problems concerning probability. In a factory, 60% of the employees are men. So this is M, and this is 60% as a probability. From here, I can automatically say that if 60% of the employees are men, this means that 40% of the employees are not men or women. 80% of the men are single, not 80% of the employees, 80% of the men are single. So these are the men, 80% are single. Consequently, I can state that 20% are not single. They could be married, widowed, and so on. And 70% of the women are single. So 0.7 of the women are single, consequently 0.3 are not single. In fact, this is called a probability tree. It's very easy, and the work in probability trees is very easy. It simplifies all the probabilities, and you will see that students like to work with probability trees. You see here in the tree, the sum always leads to 1. 0.6 plus 0.4 is 1, 0.8 plus 0.2 is 1, 0.7 plus 0.3 is 1. Now, one employee is randomly selected and interviewed. In fact, here you have to pay attention that while working in probability tree, you cannot choose more than one piece. You cannot choose more than one item. So when the question states that one employee is randomly selected, this is also a key to show that the probability tree works. Whereas, let's say the question was two employees are randomly selected. In that case, we cannot use the tree. What do? We're going to see later. Consider the events. M is a man, S is single. Calculate the probability of M. Now here we go back to the tree directly, automatically, and see the answers. What is the probability of selecting a man? It's 0.6, simply. Now what is the probability of S given M? This is a conditional probability case, so we come to the man section. We come to this section only. And from this section, we find the probability of choosing a single person. So from the man section, the probability of selecting a single person is 0.8. So it's directly also taken from the tree. And prove that the probability of S intersection M is 0.48. Here we use the formula. What is P of S intersection M? It's the probability of S given M times M, which is 0.48. Now students here might automatically state that P of S intersection M, we just have one S and M at the same time, which is here, this is M, this is S. They automatically multiply 0.8 by 0.6 without stating the formula, and this is accepted. Now what is S intersection M bar? So we come to S and M bar, we just have this M bar and this S, so it would be 0.7 times 0.4 automatically, which is 0.28. Now find P of S. P of S here we use the total probability, it's S intersection M plus S intersection M bar, which is 0.76. Now one might ask here, why did we get P of M directly from the tree and we cannot get P of S directly? Pay attention, because M appears only once whereas S appears twice. For M, this is the probability of M, but for S we have an S here and we have another S there, so we have to add the probabilities of their intersections. Now, are the two events M and S independent? To justify. To be independent means the probability of A intersection B is P of A times P of B, or the probability of A given B is P of A, and we have many probabilities here. What I did is that I found P of S times P of M, I know them. This is P of M, which is 0.6, and this is P of S. I found the product, this is 0.456. It's not equal to the probability of S intersection M, which is calculated here. So we can state that M and N are not independent. Now the selected employee is not single. Calculate the probability of being a woman. Let's translate this verbal statement into probability. This is the probability of M bar given S bar, because we need the probability of being a woman. So this is M bar and it's not single, this is S bar. We apply the property, and for S bar intersection M bar, we didn't calculate it before, but it is calculated directly from the tree. This is M bar, which is 0.4, and this is S bar. And the probability would be half. Well, notice here that when I put a frame around the number, like this number, for example, this means that this number is not given, but I deduced it from the tree. Now, in order to generalize, let's see. If this is A, this would be the probability of A, and this would be A bar, and this is its probability, and the sum is 1. And if this is B, this would be the probability of B given A and not the probability of B. And here we're going to have the probability of B bar given A. Here we have B given A bar. And here we have B bar given A bar. Now this illustration helps you a lot while working in probability trees. Now let's continue talking about the same story. We are still in the same factory and see what's happening. Firas, the owner of the factory, knows that there are 200 employees in this factory. Now, when we know the total number of employees in the factory, we can translate the tree into a table. And let's see why. So these are the 200 employees. On the Labor Day, Firas decides to select randomly and successively without replacement. Pay attention, randomly and successively without replacement, a group of 3 employees to give them 1 month salary as bonus at the end of May. Now here we have to select the 3 items, the 3 pieces, and in case we want to select more than 1 piece, as I said before, we cannot use the tree. So what do we do in this case? We translate the tree into a table. Let's see, this is the table. We have man, a woman, and we have single and not single. Well, the 200, this total is going to be put here. Now we know from the tree that 60% of the employees are men, and 60% of 200 is 120. So we have 120 men. This is the total of men. Consequently, we have 80 women in this factory. So this would be the total of women. Now, out of the men, which means that out of the 120, we know that 80% are singles. So 80% not of 200, but 80% of the men, which means that 80% of the 120, which is 96, are single. And if 96 are single, we're going to have 24 non-single, as you see here. And out of the women, we know that 70% are single. So out of the 80 women, 70% are single. This means that 56 women are single. Consequently, 24 are not single. Well, we can see from here that the information given from the tree will fill these numbers in the table only, but in order to tell the total of single and not single, we just add them. So these two totals, which are 152 and 48, do not appear on the tree. Let's see, calculate the probability of selecting exactly 2 women. So remember, in this case, we are selecting 3 employees successively without replacement. Now we need to have exactly 2 women. So this would be the probability of MWW, and don't forget the order, and this would be the answer. Now calculate the probability of selecting exactly 2 men. Well, to have 2 men, this is the probability of MMW times the order that leads to this answer. Now, knowing that the probability of selecting 3 women is 2054 over 32835, find without calculations the probability of selecting 3 men. Now, we know here that the probability of 3 men is going to be 1 minus the probability of 1 man, 2 women, or 2 men, 1 woman, or the probability of 3 women, which is given here. And this leads to this number.